Hi, I'm Steve Matza. Glad to be a member of the Tesla Society and all the other Tesla people. I manage an aircraft repair shop in Ronkonkoma, Consolidated Aircraft. We repair everything on a plane but radios, and one of the things that we specialize on is alternating current generators. We repair a whole lot of them, and they all use Tesla technology. Tesla puts food on my table, so I'm very glad to honor him. And I do a lot of teaching about basic alternating current power generation. When I do exhibit, I usually have 2 large tables set up, and I have about 20 different items on display. I have a Tesla coil, a Jacob's ladder, a plasma globe, and a bunch of high voltage aircraft equipment. One of my great memories was at the City Science Fair in Brooklyn 5 years ago. I was explaining the left-hand rule of power generation to a father and son. I was holding the father's hand as if he was shooting a gun. The fingers are going in 3 different directions. The middle finger explains north to south on a magnet. The index finger is a wire, and the thumb is the direction that the wire is moving. If the wire goes up in the direction of the thumb, the electrons go this way in the wire. So it's a very important piece of AC power generation science. The father and son were quite mesmerized at this explanation, and these are some of the illustrations I have on the table when I'm at science fairs. The first one is the left-hand rule of power generation. It shows how the 3 fingers illustrate which way electrons get pushed when they're near a magnet. You can either move the magnet near the wire or move the wire near the magnet. Doesn't make any difference. The next illustration is the wiring inside of a Tesla coil. It's basically 2 transformers with a special little circuit that raises the frequency up, and you get a very high voltage coming off of the metal dome at the top. The next one, for you geeks out there, shows the difference between volts, amps, and ohms. Volts, or voltage, is the push or pressure behind the electrons getting pushed through the wire. Amps are the amount of electrons passing a particular point per second, and ohms is the resistance in the wire. A smaller wire has more resistance, and you have less current going through a smaller wire, sort of squeezing the wire smaller. A larger wire obviously can handle more electrons going through it. The electrons is amps. And this illustration shows the structure of atoms. You have the nucleus in the middle and the electrons whizzing around it. The electrons jump from atom to atom. When the electrons jump back and forth, that's alternating current. When the electrons go in one continuous direction, that would be direct current, what comes out of a battery. Now I have a nice little picture. This is why I keep doing this. This is a young boy thrilled to play with a Jacob's ladder, a high voltage spark that goes up 2 wires. You'd see it in a Frankenstein movie. And can you see the expression on his face? He's just having a ball playing with all this high voltage stuff. And now we'll show you some other gadgets that have been on my display table. Here we have an 8-inch Tesla coil that puts out about 8,000 volts. When I energize the interrupter circuit, that's about a 2 centimeter spark. The resistance of air is about 4,000 volts per centimeter. So we're getting a 2 centimeter spark, so we got about 8,000 volts. I can also draw the spark to my ring. It's 8,000 volts, but the current is extremely low. It's microamps. So the energy is going all around my ring, and it doesn't hurt. If you put your finger straight at the ball, it would sting sort of like a bee. And what everybody likes to see is a neon bulb near the Tesla coil. The Tesla coil is putting out a high frequency radio signal. The radio signal is exciting the neon atoms. The electrons in the neon atoms are jumping out to a higher shell, and when they relax to where they belong, they give off an orange photon. The kids just love to play with this. They fight for the bulb at the science fairs. If you do buy a small Tesla coil, never touch the discharge ball with a bare finger. It hurts and stings. I actually had one child touch it and start to cry. Now we have our next display. Here is one of the displays I have out on the table at the science fairs and the Shoreham festivities. This is a 4-pole magnet out of a Learjet emergency generator. It's a $10,000 magnet out of an airplane. It's got 4 poles, north, south, north, south. As I spin it near a large coil of wire, you see you get an alternating current on this meter. The needle is alternating back and forth, and we're getting about 30 millivolts, 30 thousandths of 1 volt. All right, and again, this is Tesla technology, and also goes back to that left-hand rule of telling you which way the electrons are getting pushed inside the coil. All right, now this is a very basic type of alternating current generator, and I'll show you an improvement on this in a moment. Here we have an improvement on that permanent magnet. This is a 6-pole rotor. When I energize it off of a small 12-volt battery, right now, there's no indication on this compass that it's magnetized. When I push on the power switch, you see you get a very strong north-south indication on the compass, and it creates a very strong magnetic field. You'd be hard-pressed to pull this bolt off it while I have my finger on the button. So when it's turning in the aircraft gearbox is turning this 8,000 times per minute, 8,000 RPM. It's turning inside this large stator assembly. All right, it's 3 coils of wire, 120 degrees apart. There are 3 coils of wire in here. And as it turns, you get 3 pulses out of the 3 output wires. From one output wire to another output wire is 208 volts. From an output wire to the neutral connection is 120 volts. So that's how houses get both voltages. Houses usually get 2 power leads and a neutral. This is Tesla's claim to fame. This is what he designed 100 years ago, and this is what powers up our society. If he didn't invent it, somebody else would have invented it many years later, but he was the genius that figured it out. This is what makes the world what it is today. Alternating current. It made Mr. Edison looked like a fool. Edison was a stubborn man and thought battery power or DC generators could do it, but the DC power generators can't travel more than about a city block without using huge wires. Alternating current, you can use small wires and transmit for hundreds of miles with virtually no loss of power. That's it. Thank you, Mr. Tesla.